Welcome to the DIY Honda Garage channel. Welcome to our presentation on the diagnostic trouble code DTC P1116, which indicates an issue with the ECT or Engine Coolant Temperature Sensor 1 circuit range or performance. This problem typically arises within Honda Accord models from 2008 to 2012. The ECT sensor plays a critical role in monitoring the temperature of the engine coolant and relaying that information to the Engine Control Module, ECM. The ECM then uses this data to manage engine performance and emissions control effectively. The ECT sensor is usually located near the thermostat housing, making it relatively accessible for troubleshooting. Understanding this diagnostic trouble code is essential for accurately assessing vehicle performance and ensuring efficient operation of the engine. DTC P1116 specifically pertains to the Engine Coolant Temperature ECT Sensor 1 circuit, which is vital for monitoring engine temperature. The primary role of the ECT sensor is to provide the ECM with real-time data regarding the coolant temperature, which is crucial for various operations, including fuel management and engine diagnostics. Located near the thermostat housing, this sensor gives the ECM vital information necessary for optimal engine performance and emissions control. Any malfunction in this sensor or its circuit can lead to inaccurate readings, causing the ECM to make suboptimal decisions regarding engine performance. Corrections for any detected issues are critical, as they can drastically influence engine efficiency and longevity. Several potential causes can result in the P1116 DTC being triggered. The most common cause is poor connections or loose terminals at ECT Sensor 1 or ECT Sensor 2. These electrical connections can become damaged or corroded over time, leading to insufficient data being transmitted to the ECM. Another significant cause could be a faulty ECT Sensor 1 itself, which would directly impact the accuracy of temperature readings. Sometimes, issues with ECT Sensor 2 can also trigger this DTC, particularly if both sensors are providing conflicting data. Lastly, the ECM itself may have faults or issues that could misinterpret the readings it receives from these sensors. All these potential causes necessitate a thorough examination during troubleshooting. When experiencing DTC P1116, the driver might observe several troubling symptoms. One of the most significant signs is engine overheating, as improper readings from the ECT sensor can lead to a lack of necessary cooling. Consequently, this can result in poor fuel efficiency, since the engine might operate under less ideal conditions. The check engine light will also typically activate, alerting the driver that there is a malfunction within the vehicle's electronic system. Furthermore, the engine may exhibit erratic performance, such as stalling or rough idling, as the ECM struggles to optimize fuel delivery and ignition timing with faulty temperature data. Recognizing these symptoms is vital for prompt diagnosis and remedying the problem. The first step in troubleshooting DTC P1116 requires assessing the connections at the ECT Sensor 1 and ECT Sensor 2. Poor connections or loose terminals can severely affect the sensor's performance, and along with it, the accuracy of data transmitted to the ECM. Begin by visually inspecting these connections for any signs of wear, corrosion, or damage. If connections or terminals appear faulty, repairing or replacing them is crucial. After addressing any connection issues, proceed to the next step to ensure that the problem has been rectified. This foundational step is essential, as any unresolved electrical problems will affect subsequent diagnostics. For the second troubleshooting step, start by turning the ignition switch to the on-I position without starting the engine. Once the ignition is on, employ the Honda Diagnostic System, HDS, to check for any pending or confirmed DTCs. This system enables technicians to easily access error codes that may provide additional insights into the vehicle's performance issues. It's essential to check if DTC P1116 appears alongside any other codes, particularly DTC P2183. If P2183 is also present, this indicates a more complex issue related to coolant temperature readings, necessitating further targeted troubleshooting steps. Ignoring these additional codes could lead to misdiagnosis and inefficient repairs. In this step, start the engine and allow it to idle for a duration of approximately 10 minutes. This waiting period allows the engine to reach its normal operating temperature, which is key for accurate testing. After idling, utilize the HDS to check the data list, specifically for ECT Sensor 1's temperature reading. It's essential to determine if this reading approximates 113 degrees Fahrenheit, 45 degrees Celsius, or less. If the reading reflects this temperature or lower, this suggests that the ECT sensor might be malfunctioning, and replacing it will likely resolve the issue. Alternatively, if the sensor's temperature reading exceeds this threshold, further diagnostics will be necessary in subsequent steps to isolate the problem effectively. Upon completing the previous check, turn the ignition switch to the lock 0 position, effectively shutting off any electric current. Next, allow ECT Sensor 1 to cool down to the ambient temperature, which is the temperature of the surrounding environment. Measuring and recording this temperature is crucial, as it will be used as a comparison point for further evaluations. It's important to ensure that the sensor has sufficiently cooled down, since this influences the accuracy of the next steps. This step essentially resets the conditions for measuring the ECT's performance and accuracy, thus setting the stage for the subsequent diagnostic checks. In this step, turn the ignition switch back to the on, second position to prepare for data logging. Quickly check the HDS for the ECT Sensor 1 value in the data list, and take note of this reading. It is crucial to compare this recorded reading with the previously noted ambient temperature. The purpose of this comparison is to determine if the sensor reading deviates by 5.4 degrees Fahrenheit, or 3 degrees Celsius or more from the ambient temperature. A significant deviation indicates a fault within ECT Sensor 1, which necessitates replacement. In contrast, if the values are consistent within the specified range, it suggests an intermittent failure, signaling that other issues, such as loose connections, may still need examination. After completing the necessary repairs, especially if ECT Sensor 1 or related components have been replaced, it's imperative to perform final verification steps. Start by rechecking all connections at ECT Sensor 1, ECT Sensor 2, and the ECM to ensure that they are secure and undamaged. Following verification, the next step is to clear the DTCs from the system using the HDS. This action resets the diagnostic systems, clearing any previous fault codes. After clearing, conduct a test drive to see if the issues have been resolved. Monitoring the vehicle's performance during the drive will help to ensure that the repairs were effective, allowing the ECM to receive accurate data from the ECT sensors. This verification process is crucial to confirm that the underlying problem has been fully addressed. To prevent future occurrences of DTC P1116, implementing a routine maintenance schedule is essential. Begin by regularly checking the connections of the ECT sensors to ensure they remain secure and free from corrosion. Wiring should be inspected for any signs of damage, such as frays or abrasions that could disrupt electrical flow. Schedule periodic inspections of the ECT sensors to ensure their functionality. Ideally, this should coincide with regular oil changes or other planned maintenance. Such proactive measures will play a significant role in maintaining optimal engine performance and efficiency over the span of the vehicle's life, minimizing repairs associated with sensor failures. In conclusion, understanding DTC P1116 as related to the Engine Coolant Temperature Sensor 1 is essential for effective troubleshooting. Recognizing the symptoms and potential causes, such as poor connections or faulty sensors, can expedite the diagnosis process. Following the outlined diagnostic steps accurately will guide technicians in identifying and resolving the issue promptly. Additionally, maintaining preventive measures ensures that such faults are minimized and keeps the vehicle running efficiently. By taking these steps, you can significantly extend the life of your Honda Accord and enhance its performance, ensuring a smoother driving experience. Please like and subscribe to the channel. See you next time.